Hello and welcome to Quantum Pi. So this is day 2 of this lecture series. On the day 1 we have discussed the strategy to solve and attempt at least 50 to 55 questions in your CSAT paper. And today we will be starting number system and we'll be learning the concepts of divisibilities and remainders, and we will solve some PYQ. So you can check yourself how you are applying your concepts into solving problems. So without further ado, let's start the session. So let me give you few basic concepts of remainders and divisibility. Let me start with divisibility rules. So most of you might have known most of the rules, but let me brief them. So divisible rule of 1, one can divide any number. Now let us look into the divisible rule of the family of 2. So the divisible rule of 2 is the last digit or the units digit should be divisible by 2. So what is the divisible rule of 4? So divisible rule of 4 is the last two digits of a number should be divisible by 4. Then what is the divisibility rule of 8? So the last three digits should be divisible by 8. So if you can observe, the pattern is this is 2 power 1 and this is 2 square and this is 2 cube. So the next divisible rule will be 2 power 4, which is your 16. Now you can tell me what is the divisible rule of 16. The divisible rule of 16 is the last 4 digits should be divisible by 16. That's it. So you can go on. Now let us look into the divisible rule of 3. Divisible rule of 3 and 9. Divisible rule of 3 and 9. Sir, the divisible rule of 3 and 9 is the sum of the digits. Sum of the digits. Sum of the digits should be divisible by 3. Then the number is divisible by 3. The same sum of the digits should be divisible by 9. Then the number is divisible by 9. So if I give you a question like 2, 4, 5, 7, 6, 3, 2. If I give you a question like this, is this divisible by 3? Just add them up. 6, 9, 11, 11, 18, 18, 24, 24, 27, 28, 29. 29 is divisible by 3? No. So this is not divisible by 3. Alright, let us check if it is divisible by 9. Even with the 9, is it divisible by 9? I don't think so, because 29 is not divisible by 9. Then comes the concept of remainder. See, when they are not divisible by 3, then what is a remainder? See, I already told you the sum is 29. So when 29 is divided by 3, what is the remainder? 3 nines 27. So remainder is 2. Similarly, when 29 is divided by 9, what is the remainder? What is the remainder? Remainder is 9 2 is 18, 9 3 is 27. Again, remainder here is also 2. So this is how you can solve. You can, using the rules of divisibility, you can find whether a number is divisible by particular number or not. And if not, you can also find the remainder. If it is divisible, you know that the remainder is 0, right? Yeah. Now let's move on to finding the divisible rule of other numbers like 5. So divisible rule of family of 5. So divisible rule of 5 is simple. The last digit should be divisible by 5, which means it has to be either 0 or 5. Whatever the divisible rule of 25, which is 5 square, right? 25 is the last two digits should be divisible by 25. So it can be, it has to be either 0 0 or 25 or 50 or 75, right? So these are all the four cases. So this is 5 power 1, so last one digit. So this is 5 square, last two digits. And next comes 5 cube. What is 5 cube? 5 cube is 125. So what is the divisible rule of 125? The last three digits should be divisible by 125. So on, you can derive the your own rule for the divisible rule of other powers of 5. Now let us look into the divisibility rule of 10, and I can call it the family of 10. So divisible rule of 10 is your last digit, single digit has to be 0. Divisible rule of 10 square is the last two digits has to be two zeros. Divisible rule of 1000 is 10 cube, so last three digits has to be three zeros. I hope till here the divisibility rules are very clear, right? Now I am moving on to some important divisibility rules where most of the questions are asked from. Yes. Now let us find the divisibility rule of 11. Rule of 11. So divisible rule of 11 is very simple. So you have a number and these are the digits of those number. So let me highlight these numbers. So this is your first number, second number, third, fourth, fifth and sixth. So what the divisibility rule of 11 is? Sum of the digits in this odd places. Sum of the digits in the odd places minus sum of the digits in the even places minus sum of the digits in the even places should be divisible by 11 or it should be 0. I repeat, sum of the digits in the odd places minus sum of the digits in the even places, this should be either 0 or any number which is divisible by 11. So now if I'm talking about 121, if I talk about 1331, these are all divisible by 11. We know that. Let us see some of the digits in the odd places. 1 plus 1 is 2 minus even places 2 is 0. Yes. So this is divisible by 11. Now let us find this. So 3 plus 1 is 4 minus 3 plus 1 is 4. So you can tell that yes, this number is divisible by 11. So there will be some question like this. 3, 4, 7, 6, 5, 1, 2, x 3, 5. This is divisible by 11. Then find the value of x. Find the value of x. Very simple. The sum is 6, 12 and 16. So this is x plus 16 minus 5, 10 and 17 and 20. So this should be either 0 or a number divisible by 11. Number divisible by 11 is nothing but multiples of 11. 11, 22, 33, 44, whatever it is. So now you can clearly tell that the value of x is 4. So if the value of x is 4, then the number is exactly divisible by 11. So see, now let us see what kind of questions can be asked. Based on divisibility concepts, how questions can be framed. See, there can be different ways of asking questions. For example, they will give you a number. They will give you a number like this: 257635. So they would ask whether this number, first type of question is, they would ask whether this number is divisible by a certain number 3 or not. Second type of question is, if it is divisible, definitely the remainder is 0. If it is not divisible, what could be the remainder? So they'll ask you what is the remainder, when it is divided by 3. The third type of question would be, what should be subtracted, from the given number so that it is divisible by 3. And the fourth type of question is, what should be added to it so that this number is divisible by 3. And the last one is, find the missing digit. Find the missing digit when it is divisible by 3. Just like in the previous question, we already did, right? So we found the missing digit x. So this is one type of question they ask. Now look into this. What is the divisibility rule of 3? Sum of the digits has to be divisible by 3. So you just keep adding them and solve them. But I don't even recommend that. Instead of adding, you can just cancel it right over here, right? So 6 is divisible, 3 is divisible by 3, 6 is divisible by 3, 7 plus 2 is divisible by 3, 5 plus 5 is 10. Is 10 divisible by 3? No. So this number is not divisible. This number is not divisible by 3. Not divisible by 3. So there exists a remainder. What did we get? The sum is 10. 10 divided by 3. So what is the remainder? 10 divided by 3. 3 3s are 9. So remainder is 1. So what should be subtracted from this whole number such that it is divisible by 3? See, remainder is 1. Definitely you have to subtract the remainder. So if you subtract the remainder, there will be nothing remaining, right? So what should be subtracted? 1 should be subtracted. 1 to be subtracted. 1 to be subtracted. What should be added? So already there is 1. 1 is extra, 1 is remaining. So for that remaining 1, if you add 2 more, this will become 3. Then it will be divisible, right? Then it will be divisible. So what should be added? You should add 2 to be added, 2 to be added, because we already have 1 remaining. If you add 2 to that 1, it becomes 3, which is divisible by 3. So the last pattern would be finding the missing digit, So they would give a number and they would miss a digit. They would put an x or y and they will ask you to find that digit when it is exactly divisible by 3. So all these are all 5 different kinds of questions they ask you based on the divisibility rules. And next, so if I observe the previous year questions from UPSC CSAT, most of the questions are related to a composite number divisibility rule. Next, we will find the divisibility rule of composite numbers. Divisibility rule of composite numbers. Composite numbers. Till now, we have learned the divisibility rule of prime numbers. See, this is 2 and its family 3 and its family 5, and then we have gone to finding the divisibility rule of 11, right? So we'll see how do you do about finding the divisible rule of composite numbers. For example, you have a composite number 6. So what is the divisible rule of 6? So divisible rule of 6 is, see, let me find the factors. It is 1 into 6 and 2 into 3. 2 into 3. So divisible rule of 6 is the number has to be, so if a number has to be divisible by 6, it has to be divisible by both 2 and 3. Both 2 and 3. So the divisible rule is what? The divisible rule of 6 is should be divisible by both 2 and 3. See, whenever you are choosing 2 and 3, you have to make sure that these are co-primes. These are co-primes. For example, if I talk about divisible rule of 12, your factors would be 1 into 12, 2 into 6, 3 into 4, right? Now you cannot tell that the divisible rule of 12 is if a number is divisible by 2 and 6, it is divisible by 12. If it is divisible by 2 and 6, it is divisible by 12. This is a wrong way of doing it because they are not co-primes. What are co-primes? Co-primes are the numbers whose HCF is 1. Their highest common factor is 1. When I look into 2 and 6, their HCF is 2. You have 2 as the common factor, right? So what is the right divisible rule? When a number is divisible by 3 and 4, because they are co-primes, then it is divisible by 12. So what is the divisible rule of 12? 3 and 4. It should be divisible by 3 and 4. Now you wanted to find the divisible rule of 24, for example. So you have 2 12s and 3 8s, 4 6 24. That's it, right? So you have to check which of these are co-primes. So 2 and 12, no. 3 and 8, yes. The highest common factor is 1. So these are not. So what is the divisible rule of 24? If the number is divisible by both 3 and 8, then it is divisible by 24. So I told you, I'll tell you a better way of doing it. Just do prime factorization for 24. You get 2 12s, 2 6, 2 3s, right? So put all 2's together and the other one together. So this is 2 into 2, 4, 4 2's are 8. 8 and 3. 8 and 3. Similarly, in the previous question, we did about 6, right? 6 is just 2 and 3. And after that, we did 12, right? 12 is 2, 6, 2, 3. So put all 2 together, all 3 together. So what is the divisible of 12, sir? That is 4 and 3. 4 and 3. If they ask me to find the divisible rule of 50, what is the divisible rule of 50? So the divisible rule of 50 would be same prime factor as that. So it is 2 into 25. This is 5 into 5. So for a number to be divisible by 50, it has to be divisible by both 2 and put all these 5's together. 5 5's is 25. So divisible of 50 is, it should be divisible by both 2 and 25. So I hope this is very clear to you all. They would ask you what is the divisible rule of 200. They would ask you what is the divisible rule of 240. Finally, let us find the divisible rule of 240. So yeah, so it is 2 20s, 2 6 12. This is 3 20s and 2 tens, and you get 2 fives. Put all your 2's together. So 2 to 4, 4 to 8, 8 to 16. So divisible rule of 240 is it has to be divisible by 3, it has to be divisible by 5, and it has to be divisible by 16. If these three are satisfied, then you can tell that the number is divisible by 240. Now I'm going to teach you something which the UPSC CSAT paper focuses on. It is the divisibility rule of 1001. Divisibility rule of 1001. Before knowing the divisibility rule of 1001, let me revise something. What is the divisibility rule of 11? What is the divisibility rule of 11, sir? Divisibility rule of 11 is the digits in the odd places. The digits in the odd places minus the digits in the even places. The sum of the digits in odd minus sum of the digits in even should be either 0 or a number divisible by 11, right? Yes. Now, I'll tell you what is the divisibility rule of 101. 101. 101 divisibility rule is as same as this 11. Here you are separating one digit at a time, right? So you separate two digits at a time here. So now your divisibility rule of 101 would be sum of the digits in this odd set. This is set 1, set 3, right? Set 2. So sum of the digits in this even set should be, again, I'll write sum of the digits in odd places taken 2 at a time. 2 at a time minus sum of the digits in the even places taken 2 at a time should be either 0 or a number divisible by 101. Now let's go to 1001. I hope now you remember what is the divisibility of 1001. It's very simple. You separate three digits at a time. You take three digits at a time and you'll solve it. So sum of the digits in this odd set minus sum of the digits in the even set, right? Sum of the digits in the odd set, odd place where you're taking three digits at a time minus sum of the digits in the even places taken three at a time should be 0 or a number divisible by 1001. Should be divisible by 1001. Now let me tell you one thing. Sir, what is the divisibility rule of 6? I said it should be divisible by both 2 and 3, right? Because this is a composite number. This is a composite number. So now, if any number which is divisible by 6, it should definitely be divisible by 2 and 3, right? Yes or no? In the similar lines, 1001 is also a composite number which is product of 7 into 11 into 13. So 1001 divisibility rule, I can take the divisibility rule of 1000 as same as the divisibility rule of 13, 11 and 7, because if some number is divisible by 1001, definitely it should also be divisible by 7, 11 and 13. So now that is why I deliberately left the divisibility rule of 7 while we are doing it in the beginning. So what is the divisibility rule of 7, 11 and 13? Individually we can also use the divisibility rule for 7, 11 and 13 will be as same as the divisible rule of 1001, because if it is divisible by 1001, definitely it should also be divisible by 7, it should also be divisible by 11, it should also be divisible by 13. So when you get questions based on the divisible rule of 13 and 7 and 11, you can use this rule. You can use this rule. Take three digits at a time and sum of the digits in the odd places or the odd set minus sum of the digits in the even places or the even set. This has to be 0 or a number divisible by 1001. I hope this is very clear, right? Now let me put a few things. 11 divisible rule is known to you. So if I give you any number like 22, 44, 77, any number of this form is divisible by 11, right? Because 2 minus 2, 4 minus 4, 7 minus 7. So any number of the form AA, any number of the form AA is divisible by 11, right? Now if I take here, if I take 101, see you are subtracting this set minus this set, right? So any number of the form AB is divisible by 101. So 24, 24 is a number which is divisible by 101. 37, 37 is a number which is exactly divisible by 101 because we are taking 2 to set. We are subtracting 37 minus 37. Yes. Now you can tell that 1001 divisibility rule. So any number of the form ABC and ABC is definitely divisible by 1001 because you are making a set with these three digits and you're subtracting. So any number which looks like this 327, 327, yes, this is divisible by 1001, 142, 142, yes, 243, 243, 243, 243, yes, because this is 243 plus 243 minus 243 plus 243. So I think this is very clear, right? So there are several instances where questions based on this 1001 rule have been in UPSC exams. So this is a very favorite topic of UPSC. Now let us talk about reminders. Let us see some concepts on reminders which will help you solve the problems a bit faster. All right. Yeah, reminders. Sir, let me take a question. What is a remainder when 8 is divided by 5? What is a remainder when 8 is divided by 5? So you all know that the answer would be 5 ones are 5, so 3 is your remainder. So let me write in a different way. So 8, I write like this. So 8 I can write as 5 plus 3 by 5. So 5 by 5 remainder is 0, remainder. And 3 by 5 remainder would be 3. So your final remainder would be 0 plus 3, which is your remainder 3. Now I'll write this in another way. Instead of writing 5 plus 3, I'll write 8 as 10 minus 2 by 5. This is also 8. So 10 by 5 remainder is 0 minus 2 by 5 remainder is 2. So 0 minus 2 will give you minus 2. So this is your positive remainder and this is your negative remainder, right? So nobody will ask you to find the negative remainder. Everybody will ask you what is a remainder, and remainder will definitely be positive. So you have to convert this negative remainder to positive remainder. How do you convert? So your negative remainder is minus 2. You will have to add the divisor. What is the divisor? 5. So you will have to add 5. Yeah. So let me add 5. So minus 2 plus 5 is your 3. So this is your positive remainder. That is what you got here. So you can use this concept to speed up your remainders based questions solving, right? Yeah. So to convert your positive remainder to negative, you subtract your divisor. Here you added your divisor. You'll subtract your divisor 3 minus 5, which is minus 2. This is the same negative remainder which we got here. Okay. So why are we learning this negative remainder and positive remainder concept? For example, if I give you a question like this, if I ask you 343 plus 77 plus 62 when divided by 5, what is the remainder? What is your remainder? What you generally do is you add them up and you divide by 5, you'll get the remainder. But here we can do it very simply, 343 by 5 remainder is 3 plus here 75 goes, so 2, here 60 goes, so again 2. So you finally got 3 and 5 and 7. So 7 by 5 remainder is 2. This is your remainder, right? So like this, you can speed up your solving abilities with regards to remainders, right? Now let me give you some other question like this. If I ask you 1956 into 1955 into 1954 divided by 19, what is your remainder? So it's a waste of time if you just multiply all these. You get a very big number, 7-8 digit number, and then divide by 19, right? So what I do is I'll just simply divide one number, 1956. This is 19 ones and this is 19 ones, 19. 19 threes are 57. So 19 twos are 38. 38 and 56, you get remainder 18. So 1956 by 19, your remainder is 18. and this is 1955, one digit less than this, so here remainder is 17, and here your remainder is 16. So finally you got the remainders are 18, 17, 16. Now you can multiply 18, 17, 16 and solve it. But even then, it consumes a lot of time, right? So let me convert this 18 by 19 to a negative remainder. So 18 divided by 19, positive remainder is 18. Negative is 18 minus 19, which will be minus 1. So this is minus 1 into, this is minus 2 here, 17 by 19, and this is minus 3. Now it is easy to multiply. So if you multiply this, you get minus 6. So minus 6 is your remainder. But your remainders should always be converted to positive. So minus 6 plus 19, which is your 13. 13 is your final remainder. Am I clear? I hope so, right? Let's move on to the next part. So I have a few more questions. Let me put few questions here. 3 power 40 divided by 2. What is your remainder? It's very simple. 3 into 3 into 3. How many times, sir? 40 times, right? Divided by 2. For every 3 by 2, your remainder is 1, 1, 1, 1, 40 times. So your final remainder is also 1. Next one. Let me give you this question. 2 power 40 by 3. So this is 2 into 2 into 2, 40 times by 3. For every 2 by 3, remainder is 2. Let me convert to negative remainder, because if I multiply 2 into 2 into 2 40 times, it gives me a very big number, right? So let me convert it to negative remainder and see whether that product would be giving a smaller number. So this will be minus 1, minus 1, minus 1, right? How many times? 40 times. So when you multiply minus 1 40 times, you get 1 is your remainder. Another type of question. I'll write 2 power 41 by 3. Now you get same 2, 2, 2, 40 times. Either you get minus 1, how many times? 41 times. 41 times. So this is your final. Minus 1 is your remainder. But this has to be converted to positive. So minus 1 plus 3 will give you 2 is your final remainder. Am I clear? Now, I'll give you one more question. Let's see if you can solve this. 2 power 45 divided by 9. What is your remainder? What is your remainder? See, what would you do? You do 2 into 2. How many times, sir? 45 times divided by 9. So if you multiply 2 to 45 times, 45 times, it's a very big number, right? So you convert into a negative remainder. Negative remainder is minus 7 into minus 7 into minus 7, 45 times. So 2 into 2, 2 into 2 itself 45 times is a very big number. And now after converting into negative remainder, you're getting 7 into 7 into 7, 45 times. This is much more bigger than the previous one. So this is not the approach you have to have. So what can you do here? If I can observe here, if I multiply 2 into 2, 4, 4 2s are 8. 8 by 9 will give me a negative remainder of minus 1, right? So multiplying minus 1 is easier, right? So what I do is I'll convert 2 power 45 by 9. I'll convert 2 power 45 as 2 cube, 2 power 3, so that I get 8 by 9, right? So 2 cube whole power. So this is 3 ones, 3, 45, 15, 3 5, 15. Yes. Now I get 8 power 15 by 9, which will give me 8 into 8, 15 times by 9. 8 into 8, 15 times, or let me convert to negative remainder. So this is minus 1, 15 times will finally give me minus 1 as my remainder. But this has to be converted to a positive remainder, which will be minus 1 plus 8 plus 9. So your final remainder is 8. So your final remainder is 8. And the last part, so whenever you're dividing a number by 7, your remainders will be from 0 to 6. 0 to 6. When you are dividing by 13, your remainders range would be from 0 to 0, 1, 2, 3, 4 till 12. Remember this. Now another thing. Yeah, 5 by 3. So what do you do? 5, 3. 3 to 6. Sorry. So Yeah, so now we have 5 by 3. Let me do it by division method. So 3 ones 3. So this is 2. So this is your divisor. This is your quotient. This is your dividend. This is your remainder. We already learned in our school math that dividend is equals to divisor 3 into 1 plus 2. Divisor into the quotient plus remainder. Okay. Based on this also, there are questions asked in several exams. So you have to remember this. Based on this, they might ask you. So based on this formula, there are several instances where questions were asked. Now, I think this would be enough for you to solve these PYQs, and I have covered extensively, which is good enough for you to start solving these questions. Now, let us start with our first PYQ. So this is your 2024 question, which was asked. This is divisible by which of the following numbers? Okay. Now, so this is 222 power 333 and 333 power 222, right? So power of 2, any power of 2 will always be an even number. Any power of 2 will always be an even number. Either you will get 2 power 1 is 2, 2 square 4, 4 2 8, 8 to 16. So this is the power cycle of 2. And power of 3 will always be an odd number. So this is always an even number, and this will always be an odd number. Even plus odd will definitely give you a final odd number. So this sum is an odd number. This sum is an odd number. So odd number is definitely not divisible by 2. This is not at all divisible by 2. Not divisible by 2. So look into the options. Look into the options. Is divisible by which of the following numbers? It is divisible. It is but not 2. So you have an option telling but not 2. So it is divisible by 3 and 37 but not 2. So this is your answer. Okay, let's move to the next question. So you have 421 and 427 when divided by the same number leaves the same remainder 1. So 421, 427 and divided by a certain number, okay, leaves the same remainder 1. How many of the numbers can be used as a divisors in order to get the same remainder 1? Okay. Yeah. So see, 421 and 427 divided by the same number. So as I said, you 421, then dividend, right? This is a number. This I can write as some number. The same number is this same number is n. So n into quotient plus the remainder. Plus the remainder is 1, right? Similarly, 427 also I can write as the same number n into some other quotient 2 plus the remainder 1. Plus the remainder 1. Now if I subtract this, let's subtract this, you get if I subtract for this minus this, you get 6 is equals to this is also gone, this is also gone, you get n into q2 minus q1, right? So this number n, so 6 is 6 can be written as product of two numbers, right? So this n has to be a factor of 6. So this n has to be a factor of 6. What are the factors of 6? You have 1 and 6, and you have 2 and 3. So this n can be either 1, 6, 2 and 3. So when this n divides the number, he is telling how many numbers can be used as a divisor in order to get the same remainder 1. Same remainder 1. So you have these four possibilities, but when you divide any number by 1, you will not get a remainder 1. It is 1 is exactly divisible by 1, right? So when you divide a number by 1, you get only remainder 0. When you divide a number by 6, you get remainder from 0 to 5, as I said. So this is not at all possible. So you have three cases. These are the three possible values where n can be taken, right? So your answer is 3. I hope this is very clear. Or else we can do it the other way. See, you are dividing 421 and 427 by a number, and it is giving you a remainder 1. So if it is not giving a remainder, if it is dividing it exactly, then the numbers has to be 420 and 426, right? So that number will exactly divide these two numbers. So what is the number which can divide both these two? Is their HCF, highest common factor. If I look into this, the highest common factor is 6. So 6 is the number which can divide these two numbers, right? Now, as I said, if 6 is dividing, 1 also can divide those numbers. 6, 2, and 3 also can divide these numbers, right? But as I said, at the end, they said how many numbers can be used as a divisor in order to get the same remainder one. With 1, you do not get the remainder one. So you get 3 possibilities. 3 possibilities. This is what is this? Okay, let's move on to the next question. Yeah, we have this question. This is divisible by what? Okay, 32 power 5 plus 2 power 27. All right, 32 is 2 power 5, right? Whole power 5 plus 2 power 27. This is 2 power 25 plus 2 power 27. So when I take 2 power 25 common, you get 1 plus 2 square, which is 4. So this 2 power 25 into 5. So this number is exactly divisible by 5. Exactly divisible by 5. Option is not there, right? So if it is divisible by 5 and this is 2 power 25, I can take it 2 from here and give it to 5, right? So 2 power 24 and 10 as well. So your answer would be 10. So let's move on to the next one. Yeah. What is the remainder of an 85 into 87 into 89, 91, 95, 96 divided by 1000? This is a very interesting question. In fact, this is the easiest one if you know, if you do understand the concepts. Yeah. So this one divided by 100. So whenever they ask you some questions based on the divisibility by 100 or 10 or 1000, no, the remainders, finding the remainder is very easy. See, when they ask you what is the what is the remainder when it is divided by 10. So when you divide some number by 10, your remainders would be 0 to 9. Nothing but your units digit. Nothing but your units digit. Yes or no? Nothing but your units digit. The last digit will be your remainder. Because take any number 2, 7, 6, 5, 4. When you divide by 10, you might get anything, but your remainder would be only the last one 4, right? So when it comes to finding the remainders with respect to 10, 100 and 1000, it's all just the units digit. Okay, it's all just the units digit. When it comes to dividing a number by 100, you get tens digit and the units digit. Tens digit and the unit, because you get uh, when you divide by 100, you get remainders from 0 to 99. 0 to 99. So your remainders has to be your units digit and the tens digit. Now in the given question, we need to find this units and tens digit. But if you clearly observe this question, there is a 5 here. There is a 5 in this, right? There is a 5 in this. So 95 can write as 5 into 19. There is another 5 here. This is 5 into 17. So in this product, you are having two fives, right? And you are also having. Are you having any twos? 87, 89. In 96, you are having twos as well. In 96, you are having twos. How many twos are there in 96? I can write 96 as 4 into 4 to 8, 4, 4, 6, 10. And this again I can write as 4 into 6 or 8 into 3. Yeah, anyway, you're having this 2 square and this is 2 cube. So I'm having 2 power 5. I'm having 2 power 5. So in this whole product, I'm having 5 square is there, and there's also 2 power 5. So how many zeros would I get here in this product? Each 1 5 and 1 2 will give you 1 0, right? So you have 2 5s and 2 2s. Anyway, you have. So you'll get 2 zeros at the end. 2 zeros at the end. So this product is a number, is a number, is a number, is a very big number with last 2 zeros at the end by 100. So this will give you, it is exactly divisible. So your remainder would be 0. Your remainder would be 0. Clear? Yeah. Okay, now let's move on to the next question. Yeah, this is the fifth question. See, you can pause the video and try it yourself and check if you are able to solve it. Then you can look into the solution. So this is a question for any choices of values of xyz, the 6-digit number of the form xyz xyz. Yeah, this is just now explained you, right? 1001 divisibility rule. So if it is divisible by 1001, it is also divisible by 7, 11 and 13. So any number which is divisible by 1001 will be in the form of ABC, ABC. So it is all the same, xyz, xyz. So it is divisible by 7, 11 and 13. So this should be your answer. So let's move on to the next question. So a number n is found by writing 9 for 99 times. So n is a number, you are writing 9 for 99 times. Okay. So this is 99 times. What is the remainder if n is divisible by 13? So 13 divisible rule is as same as 1001 divisible rule. What is 1001? Take 3 digits as a set. 3 digits as a set. You add this and you subtract this, right? So if I take these 3 as a set, these 3 as a set, and next 999 as a set, so on. So this minus this gets cancelled. So you are cancelling 6 nines. Similarly, other 6 nines also gets cancelled. So we have total 99 nines. Out of 99, when you divide by 6, so 6 10 60, 5 30, 90 is gone. You still have another 9 nines. Another 6 is gone. Another set of 6 nines are gone. So you are left with 3 nines at the end. You are left with only 3 nines. So out of 99 nines, you have cancelled all 96 nines and you are left with only 3 nines. Now these 3 nines, when divided by 13, what is the remainder? So 13 sevens are 91. You are having 89. So 13 six are. So 13 fives would be 65. 13 6 would be 75 plus 3 78. So 11 is your remainder. So this is your answer. Now let us move on to the next question. Question number 7, which is your 2023 question. Do not forget, please pause the video and you can try it yourself. How many natural numbers are there which gives a remainder of 31 when 1186 is divided by these natural numbers? So this question says, so remainder of 31 when this 1186 is divided by the natural number. So let the natural number be n. So you are dividing 1186 by n. So 1186 is your dividend. So n into some quotient plus the remainder 31. So n into quotient will be 1186 minus 31, which will give you 551155. So your number would be a factor of 1155. 1155. So you should find all the factors of 1155. You will have 1 into 1155. It doesn't go with 2. It doesn't go with 3. Yeah, it does go with 3 because sum is 12. So it is 3 into 3 3 is 9. 25 3 7 is 21, 3 8 is 24, 3 5 is 15. It doesn't go with 4 because it hasn't gone with 2. So it doesn't go with 4. It goes with 5. 5 2 is 10, 5 3 is 15, 5 1 is 5. It doesn't go with the 6. It doesn't go with the. Let us check if it goes with 7. 7 1 7, 7 5 is 30. Yeah, it goes with 7. So 717 out of 11 you have 45. 7 6 42, 7 5 is 35. Next, it doesn't go with 8. It doesn't go with 9 because sum is 12. Doesn't go with 10. It goes with 11, right? 11 1 is 11. 5, so you take 0. 55, 11 5 is 55. And doesn't go with 12 because it is not going with 3 and 4. So why would it go with 12? So let us check if it goes with 13. 13 7 is 91. 13 8 is 104. 13 8 is 104. 104. You'll be left with 11 115. No. 115. Yeah, it goes no because 13 tens is 130. 115. No, it doesn't go. So yeah, with 13 it doesn't go. With 14, it's going with 7, but it's not going with 2. So 14 also it doesn't go. 15, It's going with 3 and it's going with 5, so it also goes with 15. So 15 5 75, 15 6 90, 15 7s 105. So 15 7s 105. You'll again have 10, again 105, 15 7s 105. Does it go with 16? Doesn't go, because it's not going with 2 and 4. 17, let us check if it goes with 17. See, we sometimes we have to try doing it. So 17 5s is 85, 17 6 is 95 and 102. 17 6 is 102. So you are having 5 here and 3, 135. 17 10s is 170. So 17 5s is no, it doesn't go with 17 as well. So 18, it's not going with 9. Why would it go with 18? 19, let us check if it goes with 19. 19 5s are 95. So 19 6 would be 114. Yes, 114 doesn't go. Yeah, it doesn't go with 19 as well. Now let us check if it goes with 20. Doesn't go. 21, 7 and 3. It's going with 7 and 3, so it does go with 21 as well. So 21, how many times? 21 tens are 210, 21 5s are only 105. 105 and 105. 105 and 105. Okay, done. 21 5s and 21 5s. Right. And next, 22, no, 23. 23, I think we can check with 23. 23, no, it doesn't go with 23 as well, I guess. Because with 23, you have 23 tens are 230, 5s are would be 115. No, it doesn't go with 23. 24 doesn't go because it is not going with 2. So all even numbers, it doesn't go with all even numbers. So 25, 25 also doesn't go because 25 divisible rule is last two digits has to be the last two digits has to be either 0 0, 25, 50 and 75. No, so 25 also doesn't go. 26, it's not going with 13. Why will it go with 26? 27, it's not going with 9. No, 27 as well. 28 doesn't go. 29, we have to check with 29. So 29 into 1155. So 29, 29 fours. 29 fours will be 34s are 120 minus 4. 120 minus 4, 116. No. 29 threes. 29 threes would be 90 minus 3. Now 90 minus 3 is 87. Yeah. 29 threes is 87. So you have 13 and 15. 13 and 15. 28. A remainder 285. 29, no, doesn't go. 30 doesn't go. 31. 1155. 31, right? Yeah. 31 threes are 93. You still have 7 and 15. 15 plus 7 would be 22 to 25. 31 fives. 15, no. No, it doesn't go with 31 as well. Let us see if it goes with 33. Yeah, it goes with 33 because it's going with 3 and 11, right? So it also goes with 33. Yeah. 33 threes are 99. 33 threes are 99 out of 1155. 99 is done 165. 33, yes. Threes are 33. That's it, done. So we have got how many? 1, 2, 3, 4, 5, 6, 7, 8, 16 factors we got. Okay. So he's asking which gives a remainder of 31 when divided by when it divides 1186. So to give remainder 31, those numbers, those divisors has to be more than 31, because when you divide a number by 3, the remainders will be only 0, 1, 2. When you divide by 7, the remainders will be only from 0 to 6. So any number above 31, any factor above 31 is your answer. So this gets cancelled. So your answers has to be these. So how many are there? These are 8 and this is 1, 9. So your answer would be option D. Well, I hope it's very clear, right? If you did not understand, do watch it again. So now let's go on to the 8th question. Remainder when 2 power 192 is divided by 6. Okay, all right. Now this is just 2 into 2, how many times? 192 times by 6, right? 192 times. So 2 ones, 2 threes. So your answer would be 2 power 192 times would be 191 times now by 3. So for every 2 by 3, so this is 2 into 2 into how many times? 191 times by 3. So if you multiply, it's a very big number. Negative remainders will be minus 1, minus 1, minus 1. How many times? 191 times, which will be minus 1. So you have to convert into a positive remainder plus 3. So your remainder would be 2. But here is the catch. Do not think your remainder is 3, because you have already divided initially with 2, right? You have cancelled 2 here and 2 here. So at the end, you have to again multiply by 2. So your final remainder would be 2 twos are 4 should be your final remainder. So your answer would be 8. I'll tell you a very good example where you can clearly understand this. If I tell you 15 by 6, what is the remainder? 15 by 6, what is your remainder? It's very clear. Your remainder is 6 twos are 12, remainder is 3, right? Now let me do it in this way. Uh, I will divide 15 by 3 with a common factor. So this is 3 2 6. This is 3 5 15. Now what is the remainder by 5 by 2? Remainder here is 1. But is it the same? No, because we have cancelled the factors, right? 3 and 3. So again you have to multiply by 3 into 3. So remainder is 1 into 3. So your final remainder is 3. So that is what I did over here. Because I have cancelled 2 and 2 here in the beginning, I have to again multiply back at the end. So your answer is option D, which is 4. Next. What is a reminder when 91, 92, 93, so on, multiply till 99 is divided by 1261? So we have 91, 92, 93, 94, 95, 96, and 97, 98, and 99, and divided by 1261. So we have to see if there is something which can cancel these things. Let's see 1261 factors. What are the factors of 1261? 1 into 1261, and doesn't go with 2, doesn't go with 3 because sum is different. 4 5 no, 7 7 1 756 no, 8 no, 9 no because sum is different, 10 also no, 11 11 if you see this is 3 no, doesn't go. So 12 doesn't go. 13, let us check with 13. 13 10s are 130, 13 9s are would be 130 minus 13, so 117. So 91, you are left with 91. 13 7s are 91, yes. So it is 13 9s are 117, and you get 91. So 13 7s are 91. So 13 into 97 is 1261, right? Yeah, okay, you got 97 here. So 97 ones, 97 13s is 1261, and 13 and 91 also goes, right? So 13 ones, 13 sevens. So it is exactly divisible. When it is exactly divisible, your remainder is absolutely 0. So your answer is this. Let's move on to the 10th one, which is 2022 question. What is smallest number greater than 1000 that when divided by any of the numbers 6, 9, 12, 15, 18 leaves a remainder of 3. So when you divide by 6, 9, 12, 15, 18, you should get a remainder of 3. Remainder of 3. And that has to be greater than 1000. So it's clearly a 4-digit number, right? So see, what is the number which is exactly divided by all this? First find that. So it is nothing but the LCM of those numbers. What is the LCM of all this? So to find the LCM, you know the old methods of doing what you have learned in your school, where you do like this, right? Yeah. But I prefer taking the bigger number and checking its multiples. 18 doesn't go with all this. Okay. 36, 18 to 36 doesn't go. Since you have 5, I think 18 5 is 90. Let's check 90. 90 goes with 18, 15, 12, 12 with 12, 90 doesn't go. Let us check 180 now. 180 goes with 18, 15, yes. 12, yes. Yes, yes, yes. 9, 180, yes. 6, yes. So your LCM is 180. So you have to find a number, 4-digit number, which is exactly divisible by 180. So let me divide this by 180 and check uh, what number can exactly divide this. So 180 tens would be 185s would be 900, right? Yeah, 185s would be 900. So you're getting 100, right? Okay. So 100 is your remainder. 100 is your remainder when you divide 1000 by 180. So if you can subtract that 100 from this 1000 from the given number, it is exactly divisible, but it becomes a 3-digit number. We wanted a number greater than 1000. So to make this divisible by 180, I need to add 80. So what is the number that could be added to this so that it is exactly divisible by 180 is 80. So your number has to be 1000 plus 80, which is 1080. This is the number which is exactly divisible by 180. That means which is also exactly divisible by all these 6, 9, 12, 15 and 18. Now it should leave a remainder 3. So if you wanted to leave a remainder 3, so you should have extra 3 here. So your answer would be 1083. So this is your answer. Next. Yeah, if 3 power 2019 is divided by 10, yes. Just now I told you whenever you're dividing by 10, your last digit should be your remainder. Any number 2, 7, 6, 5, 4, when you divide by 10, your remainder would be 4. Your remainder would be 4 because any number ending with 0 only can be divided by 10, right? So just find the units digit. 3 power 2019, 3 power 2019 divided by 10. Find the units digit of this. So 3 power 2019 का units digit. So what is the units digit? I'll teach you the concepts of units digit in the next session. So your class 3 will be about units digit. So the units digit of this would be, see, power of 3. Let us see the power cycle of 3. 3 power 1 would be 3. 3 square would be 9. 3 cube would be 27. So units digit is 7. 3 power 4 would be 7 is 21. Again 3 power 5 would be 1 3s are 3, 3 3s are 9, 9 3 is 27, 7 3 is 21. So 3971, 3971. So these are the only numbers which can be the units digit of 3 power 2019. So this is a cycle of 4, right? So divide 2019 by 4. So find the remainder. 5 4 is 20 and 4 5 is 20 and you still have 19, right? So 4 4 is 16, 4 4 is 16, yes. So 19. So you'll have remainder is 3. Remainder is 3. So your units digit should be 3 power 3. What is 3 power 3? Your units digit is 3 power 3. So 27. So your units digit will be 27. So this value is a very big number. Is a very big number. And ending you have a 7. And this divided by 10, your remainder will be 7. Your remainder will be 7. Am I clear? Am I clear? Yes. Now let's move on to the next question. So this number is divisible by 7. So what is the value of p? Okay. I already talked to you about divisibility of 1001. It is the same for 7, 11 and 13. So let us use that rule here. So 379, 81, 25 and you have p here 369. Okay. So divisible rule of 7. 3, 3, make a set of 3, 3 things. You add these and you subtract this, right? So 369 plus 37. This is 16, 10. So you are getting, sorry, not 369 plus 37. Sorry. 369 plus 981. 369 plus 981. Yeah. So 369 plus 981. You'll be getting 1415. So 10, 13. 1350. You have to subtract 25p and 37. Let me first subtract 37 minus 37 and this will give you 3 and this is 1 and 1313. Okay, so you're getting 1313, and you still have to subtract 25p. 1313 minus 25p. This is nothing but 250 plus p, right? So if p is 1, it is 251. P is 7, it is 257. So I can write this as 1313 minus 250 minus p. So 1313 minus 250. So 1313 minus 200 is 1113. So 1113 minus 50 you have to do. So 1250 and 13. Sorry, 1 second. 1313 minus 200 is 1113. 1113 minus 50 is 1063. 1063 minus this p should be divisible by 7. Should be divisible by 7. Now let's see what we can do here. Let us see 1063, is it divisible by 7 or not? First thing, 717, you have 36, 7 5s 35, you have 13, you have 13, you have 13. So 717, 7 ones is 7. So your remainder is 6, right? Your remainder is 6. So that 6 has to be subtracted. Yes or no? You are finally left with 13. From 13, you have to subtract 6, so you get 7, which will be exactly divisible, right? So what should be subtracted? So 6 should be subtracted. So 1063 minus 6 is nothing but 1057. This will be exactly divisible by, which will be exactly divisible by 7. So what is your p-value? P-value is nothing but your 6. Yes, so this is your answer. I hope this is very clear, right? Next, let's move on to the next question. So 13th question, which has appeared in 2021. Consider all three-digit numbers obtained using three non-zero digits, which are multiples of 3. So three non-zero digits, which are multiples of 3. Okay. And let us be the sum, which of the following is correct. So consider all three-digit numbers obtained using three non-zero digits, which are multiples of 3. Okay. What are the multiples of 3? So 3, 6, and 9. So you have to form a all three-digit numbers with 369. So one would be 369, other would be 396, other would be 639, 693, 936, and 963. So these are all the three-digit numbers, right? These are all the three-digit numbers. Okay. Consider all three-digit numbers obtained using three non-zero digits, which are multiples of 3. Okay. Let S be their sum. Okay. I have to add them. So S is the sum of all this. Okay. Which of the following is correct? S is always divisible by 74 and S is always divisible by 9. If I look into this, no, some of these digits, 9 plus 6 and 3 is 18, right? So this number is definitely divisible by 9. Uh, so every sum is the same. Every sum is 18. So every of these number is divisible by 9. So even if you add all this, and this sum, yes, is also divisible by 9. Is also divisible by 9. So your statement 2 is absolutely correct. Now we have to check about the statement 1. Now this sum should be divisible by 74. Let us add them. Let us add them. So what would the sum be? 9 2 is 18 and 6 6 12. 18 plus 12 is 30, 30 and 36. This is 36. Again, this is also 36 plus 3 is 39. Again, 3, 36 plus 3 is 39. So 3996. We have to check whether 3996 is divisible by 74 or not. Simple. Should we go with 2? Yeah, 2 3 is 6, 2 7 is 14. 2 1s 2, 2 9s 18, 2 9s 18, 16, 2 8 16. So 1998 is divisible by 7 or not? Okay. Sorry, by 37 or not? So you have to divide 1998 by 37, right? Let's do it. So 37, let us think this is 40. So 44s are 160, 45s are 200. So this is less than 40, it will be less than 200. So 37 5s are 7 5s 35, 3 5 3s are 15 plus 3 18, 185. So you'll be left with 4 and 9 minus 8 is 1. So 148. So 148 should go with 37, right? So 7 4s are 28. So let us see 37 into 4. 7 fours 28, 4 threes 12, that 148, yes. So that is 7 fours 148. Yeah, it is also divisible. The sum is the sum, yes, is also divisible by 74. So this is also right. So both statement 1 and 2 is absolutely right. So let's move on to the next question. Yeah. So when a certain number is multiplied by 7, the product entirely comprises only ones. So, okay, what is the smallest number? Okay, so when you multiply with 7, you have to get all ones, right? You can just check the options. You can directly check the options. Like multiply with 7 and check whether you're getting all ones or not. So that would be the number. It's very simple. This would save your time basically. 7 is 21, 2, 7, 1, 7, 8, 9, 90. So this is wrong. 7 is 21, 7 is 14 plus 2. 14 plus 2 is, yeah, 6. So this is also wrong. 7 is 21, 2 carry. 7 8s are 56, 57, 58, 81. This is also wrong. So 7 3 is 21, 1, 2, 7 7 is 49. You have 2, 51, 1, 5 carry. 7 8 is 56, 56 plus 5 again 1. So yeah, you get all ones. This is your answer. This is your answer. Or else you can try it some other way as well. See, you are multiplying 7 into some number which is giving you all 11s, right? So let me come with first 111. So the number should be 11 by 7. 11 by 7. 11 by 7, you cannot get such a big number. Or it has to be triple 1 by 7. You still will not get such a big number. 4 ones by 7. 4 ones by 7, you might end up with 3 ones. Or a 3-digit number, right? So let me take some 6 ones by 7. This is how many digit number? 1, 2, 3, 5 digits. So let me take 6 ones. 6 ones by 7. 1, 2, 3, 4, 5, 6. Yeah. Let us see. 7, 7, 1, 7. You have 41, 7 5s 35, 61, 7 9 63, right? 7 8s 56, 56, 56. So this is 61, right? So 51 again. 7 7s 49, 7 7s 49, 21, 7 3s 21. So see, so it is 15873. So this is your answer. Okay. So either way, but going through the options is good one as well. So it's up to you, which you're whatever you're comfortable with. Okay, next, let's move on to the next question. Yeah, how many integers are there between 1 and 100 which have 4 as a digit but are not divisible by 4? Okay, let's check between 1 and 100. So 4 as a digit. So 4, 4 as a digit but not divisible by, yeah, in 1 to 10 you only have 4. Next you'll have 14, 24, 34, 44, 54, 64, 74, 84, 94, right? Yeah. So which are not divisible by 4. This is divisible, this is divisible. So these are all divisible by 4s. So these are not divisible. 1, 2, 3, 4, and 5. You have got 5 numbers till now plus. And also with 4, all the numbers in 40s is also are the numbers which are having 4. So 41, 42, 43, 44, 45, 46, 47, 48, 49. All right. So this is divisible here and this is also divisible. How many are not divisible? 1, 2, 3, 4, 5, 6, 7. So 5 plus 7. So your answer should be 12 numbers, right? This is a very simple question. See, the UPSC CSAT is not at all a difficult paper. You can solve most of the questions. You have to be confident about solving this. You have to be relaxed. Do not take tension while you're solving, and it is doable. Not at all a difficult thing. What is the least 4-digit number when divided by 3, 4, 5, 6 leaves a remainder 2 in each case? Very simple. Any number which is divisible by exactly by 3, 4, 5, 6 is there LCM? Is there LCM? We already did a question of this type before. So yeah, LCM. What is LCM? Take the bigger number 6. 6 doesn't go with all 12. No, 6 3 is 18. Since you have 5, you have to go to 6 5 is 30. 30 goes with all? No, it doesn't go with 4. So 60? Yes. So LCM is 60. 60 goes with everything. Yeah. So it has to leave a remainder 2, and you're asking the least 4 digit number. Now chalo again start. First do it with 60 and find whether you're getting a remainder or not. 61 is 60, you have 400, so 66 are 360, you're left with 40. 40 is a remainder. For this to be divisible, I can subtract 40, but if I subtract 40 from 1000, this becomes a 3 digit number, so better I add 20, so that is exactly divisible by 60. So your number would be 1020, and this has to leave a remainder 2 when you divide. So let us add that remainder to it. So 1022 is your answer. So this is the one. Next, what is the remainder of 51, 27, 35, 62, 75 divided by 100? See, very easy. We have solved such type of questions just now. Pause the video and do it yourself. Whenever you are dealing with 100, what did I tell you? What did I tell you? Your remainder will be the last 2 digits. Your remainder would be the last 2 digits. So as I said you, these are the last 2 digits, right? So let's see how many zeros this number can make. Uh, you have a 25 into 3 here, and you have 5 into 7. So you have this 25 is nothing but 5 square, and this is 5 power 1. So you have 3 5s, 5 cube you have. How many 2's you have? Because 5 into 2 makes a 0, right? You only have 1 2 here. Well, this is 2 into 31. So because you have only 1 2, your one's digit will be only 10. One's digit will be 10. So this product is a big number which is having last 10, which is ending up with 10. So this is 0. Okay, done. Now you need to find the this number. All right, so we used 1 5 and 1 2. 1 5 is done, and 1 2 is also done. Now find the units digit. Then find the units digit. 51 into 27 into 7 into 31 into 25 into 3. So any number ending with 5, there is a product of 5 into something, you will definitely have 5 as a unit digit, right? So this product without this 5 and this 2, still you will get a 5 as your, the unit digit in this product. So this should be a tens digit. So your answer would be 50. I hope I am clear. If you did not understand, do again look into it. Pause, go back, just again look into this, try to understand what I'm trying to tell you. All right, yeah, the next question. A digit n is greater than 3 and is divisible by 3 but not divisible by 6. Acha, greater than 3 but not divisible by 6. Okay, and it is divisible by 3. So greater than 3 divisible by 3 is 6, 9, 12. These are all divisible by 3, but n is a number which is not divisible by 6. So not this. So I can suppose n is 9. N is 9, and it can also be 15, right? 15. So this is plus 6, again plus 6, 21. These are all the numbers which are greater than 3, which are divisible by 3 but not divisible by 6. Okay, so we got n can be all these numbers. Which of the following number is divisible by 4? Okay, let us take n is 9. So this will be 2 into 9, 18, which is not divisible by 4. This 3 nines 27, not divisible by 4. This is 2 into 9 plus 4, 18, 22, which is divisible by 4. No. So 9 3 is 27 plus 1, 28 is divisible by 4. Yes. So this is your answer. Now let's solve this question. We still have 3 more questions to do, and we can wrap up the session for today. Yeah. In a school, every student is assigned a unique identification number. A student is a football player if and only if the identification number is divisible by 4. Okay. Football players are multiples of 4, right? 4x. And whereas a student is a cricketer if and only if the identification number is divisible by 6. So cricketer will be a 6 multiple, right? Some 6 multiple. So if every number from 1 to 100 is assigned to the student, then how many of them play cricket as well as football? Yeah, simple. Football are the factors of 4. So it can be 4, 8, 12, so on. These cricket people are multiples of 6. Sorry, did I tell factors of 4? No, multiples of 4. Yeah, now multiples of 6. 6, 12, 18, and so on. So both players, I mean, the students who play both football and cricket will be the common multiples, nothing but 12. So 12, 24, 12 3 is 36, so on. 12 5 60, 12 50, 12 5 6, 12 6 72, 12 7 is 84, 12 8 is 96. Till 96 you can go. This is 12 ones. This is the first number, 12 ones. So this is 12, 12 eights. No, 12, 12 6 7, 12 7 is 84, 12 8 is 96, right? Yeah. So there would be 8 people who can play both of cricket and football. Yeah, very simple. Next question. A 8-digit number thus leaves remainder 0 when it is divided by 3. Very simple question. Divisibility rule of 3. I told you the sum of the digits should be divisible by 3. So instead of adding, what did I tell you? You can even cancel those. So 6 can be divisible by 3. 4 is also 4 plus 2 is divisible by 3. 7 plus 2, 9 is divisible by 3. 5 and 4 is also 9 sum. This sum is also divisible by 3. So what is left over? B is left over. So B can be 0. Even if I put 0 here, it is divisible by 3. It can be 3. It can be 6. It can be 9. So how many possible values of B are possible? We have 4 values. Let's move on to the last question of the day. If R and S are different integers, both divisible by 5. Okay. Then which of the following is not necessarily true? See, such kind of questions, you can choose randomly any of the numbers. For example, I'll choose, because R minus S is there, no? So I'll choose R as 15 and S as 10. Are the two integers both divisible by 15? Yeah. Let's see if all these are satisfying these conditions or not. So R minus S. So 15 minus 10 is divisible by 5? Yes. R plus S is divisible by 10? No. This is not happening. R into, yes. So 15 into 10 is divisible by 25? Yes, because this is 5 threes, 5 fives. Again 5 ones, 5 twos. This is also true. This square plus this square. So it is 15 square plus 10 square is also divisible by 5. Definitely here 5 ones, and here also it goes with some quotient, whatever it is. And here also it goes with some other quotient. Yeah, this is also satisfying. So which of the following is not necessarily true? So this is the answer which is not true. Yes, finally we have come to the end of the session. I hope you learned the concepts of divisibilities and remainders. I hope you enjoyed the session. Please do like the video so that it reaches more number of audience, and also share it with your friends, whoever is preparing for the same examination. And do not forget to subscribe the channel and click on the bell icon so that you do not miss on the updates, or do not miss on the videos I post on daily basis. And if you wanted the PDF, I will do share it on my Telegram channel. You can join it. Yeah, well, I'll catch you up in the next video. Till then, have a great day. Take care. Bye.